right, first of your Module 10 videos. So, and again, I think a lot of these are going to be review for you, so I'm not going to do 2 examples unless I feel like it's a trickier one, but let me know if you do need more. The first one we're going to look at is domain of a rational function. Using interval notation. Okay, so you have definitely done these before. Given a function like f of x is maybe x plus 2 over x squared minus 7x minus 18. Okay, the denominator cannot equal 0. The numerator can. All right, so negative 2 for x would be okay in this example, just as long as negative 2 won't also make the denominator 0. So we can basically just kind of ignore the numerator. It doesn't even matter. It's just the denominator that we care about. Okay, so when we do this, we will, sorry, just a second. Okay, factor the bottom. So that will factor to be x minus 9, x plus 2. Okay, which means x cannot equal 9 or negative 2. Okay, so it can't equal negative 2 because of the denominator and only because of the denominator. Okay, it has nothing to do with the numerator. All right, so then when we write this, now we want to use the interval notation. So if it were all real numbers, we'd go negative infinity to infinity. Okay, but the fact is that we need to leave out 9 and negative 2. So we want all the numbers up to negative 2, but not including negative 2. And then again from negative 2 to 9. And then again from 9 to infinity. And we put the little union symbols in between those to show or. Okay, so there's your final answer there. Just make sure you put it in interval notation like that. All right, our next one is domain of a square root function. And this one, they're subtitling it or classifying it as advanced. Okay, so when we have a function with a square root, sorry, that should be an x. V of x is the square root of negative x plus 5. Say something like that. Okay, the key here is you can't square root a negative. Okay, you can't square root a number less than 0. Okay, that is not allowed. Okay, square rooting of 0 though is allowed. Okay, that's 0. So we just need to be careful of that. All right. So what we do is we take whatever is under the square root sign. So negative x plus 5 has to be greater than or equal to 0. Okay, and then we solve that inequality. All right, negative x plus 5 has to be less than or equal to 0. Let's subtract the 5 from both sides. So negative x is greater than or equal to negative 5. And then divide by negative 1. And then since we're dividing by negative, we flip the sign. So we're going to have x is less than or equal to 5. Okay? And now interval notation again. So we want less than or equal to 5. So any values from negative infinity up to 5 and including 5. That will be our domain. Okay? And the next one here is determining whether an equation defines a function. And I know we just did this in the last one. Okay, so determining, oops, one more syllable there. Determining whether an equation defines a function. And I think in this one, for whatever reason, there are some repeats here. So I won't go through them in as much detail as the first time. This one, again, this was in Module 9. So you can look that one up if you want. I'll do an example though. The first one that popped up for me was x squared plus y squared equals 16. 8x plus the absolute value of y equals 0. X squared plus 9y equals 6. Oh, I think it was, maybe that wasn't Module 9. I think Module 9 was whether it was linear. Okay, so I take that back. All right. Y equals the square root of x minus 1. Okay. So the big thing here is that if there's a y squared, not a function. Okay, because what that means is that y could equal, I'm sorry, let's see. Yeah, I guess I shouldn't have done that. Y could equal then either the positive or negative square root of y squared. Okay, so you would have two different y values that would work for this. So if there's a y squared in it, it's not a function. Okay, so we can get rid of this one. Okay, and that's it for now. This one is going to be a function. You've seen that before. That's your square root function. So we can recognize that as a parent function there. This is going to be a function. That's a parabola. Okay, where you can get x squared. I'm sorry. We could solve it for y and you would probably recognize it better. But the fact that there's a y and an x squared. So we could rewrite it as 9y equals 6 minus x squared. Divide by 9. 6 ninths minus 1 ninth x squared. That's a parabola. Okay. Then your last tricky one is that absolute value one. Okay. So for that one, it's another one where you can get two different values for y. Okay. So I'm going to, if we have the absolute value of y, it's not a function, because we could have positive or negative values working there. Okay, so those are really the two things to look for. I don't think they're going to throw you off on any other ones than that. Okay, look for those y squares and those absolute value of y. I think those are the only ones. Let me just take a quick peek here at another problem. Absolute value of x is okay. Y cubed is actually okay because odd powers are okay, because there's only one value of y that would work. Positive and negative aren't interchangeable with odd powers, but any even powers are not. Okay, and I think that should cover it for what they're going to throw at you there. All right, next one is finding inputs and outputs of a function from its graph. You guys are going to be so good at this one. Finding inputs and outputs of a function from its graph. Okay, so you're literally just looking at a graph here. So in this first example that I'm looking at right now, they give you an upside down parabola. They give you 1, 2, 3, 4, 5, and 1, 2, 3. Okay, so I'm just getting the right points on here. Okay, so they give you a graph like this. And then they say find f of negative 2 and find one value of x for which f of x is 4. Okay, so first of all, f of negative 2, that means when x is negative 2, what's y? Okay, so when x is negative 2, y is up here, and you'll have the grid there. You'll be able to see it exactly, but it is at the point -2, 2. Okay, so f of -2 is 2. And then we want to find one value of x for which f of x is 4. So that's if y is 4, what is x? Okay, so if y is 4, then we're up here. Okay, and again, you'll be able to tell it from, oh, I'm sorry, 4. We're up here. Okay, if y is 4, then x has to be 0. That point at 0, 4. Okay, so x equals 0 would be that first one. Okay, so you're just reading the graphs for that. Next one, we have domain and range from the graph of a continuous function. Okay, so for this one, they're going to give you, just like they said, a continuous function. Okay, so the one that I'm looking at right now, it takes me longer to draw it than to explain it. Okay, so we're at -2, 5. Okay, so this is the graph that's given to me. Okay, so you want to give the domain, which would be all the x values. Oops, values. And the range would be all the y values. Okay, now what I always teach kids in my Algebra 2 class is to think about, when you're finding the domain, think about if you were to basically, I always show it with my hands, but like think if you had like a steel plate here and a steel plate here, parallel to the x-axis, and you had some sort of crank that would bring those steel plates to the x-axis and squish your function, okay, so that all of these points go to the x-axis. Okay, so you'd have an open circle here. All the points above would fall down to the x-axis, they'd be squished down, and all the points below would be squished up, and then your last point would be here. Okay, and then you just have a number line. All right, so your domain would be all of the x's, and they're going to want it in the interval notation, from -2, but remember, not including -2, right? We're going to use parentheses when you have an open circle, brackets when you have a closed circle. Okay, so we've got an open circle on -2 and a closed circle on 3. So there's your domain. Okay, and then I show them something similar for range, but you take these steel plates or your hands or whatever and push these in. Okay, then this point ends up over here. Anything to the left of the y-axis ends up on it. Anything to the right gets pushed onto it, all the way down to your last point. Okay, and then look at your number line in the y direction, right? The lowest value on it is -4, and it's a solid circle. And the highest point on it is 5, and it's an open circle. Okay, so there you go. All right, we'll get another one here. And I think some of these, again, they repeat, which is fine. You guys are going to cruise through these then if you're repeating ones that you already learned. So graphing a line given its equation in slope-intercept form. And this is with a fractional slope. Okay, so slope-intercept form, that's the one that we like. That's your y equals mx plus b. Okay, and b is your y-intercept. M is your slope. And if m is a fraction, you're going to have the rise over the run. Okay, so our example is y equals negative 1 over 4 x plus 2. Okay, so when we graph it, the first step is to find your y-intercept. Okay, so your y-intercept is 2, so we're going to intercept the y-axis at 2. Okay, now your slope is negative 1/4. So we're going to put that negative 1 over 4. You got to pick a number for the negative to go with. Okay, so from that point, I'm going to rise negative 1, which means go down 1, and run 4, which means right 4. So I'm going to go down 1, I'm going to go right 4. Okay, so down 1 and right 4. 1, 2, 3, 4. It will take me right there. Okay, and that would be the point 4, 1. Okay, where that blue one is the point 0, 2. Okay, and 2 points is all I need to be able to draw my line then, so I can fill in my line. Okay. Just like that. Okay, so the question always comes up then too, why did we choose the 1 to put the negative on? You don't have to. We can do m equals 1 over negative 4, and the 4 gets the negative. And then our rise is 1, and our run is negative 4. So you go up 1 and left 4. Okay, so I'm at my y-intercept again, and I go up 1 and left 4. Then I get the point over here at negative 4, 3. And it still gives me the same line. So it doesn't matter which one you make negative if one of them is supposed to be negative. Okay. Next one. We have graphing a line given its equation in standard form. Okay, so for this one, standard form is y equals ax. I'm sorry, that's not right. You always want to start with y equals and forget. Okay, so it's actually ax plus by equals c. Okay, the easiest way to do this is to find your intercepts. Find your x and y intercepts. And that's your 2 points that you would connect then. Okay, so your x-intercept, you make y equals 0. Your y-intercept, you make x equals 0. So the example that we're going to have here we got the line 2x plus y equals negative 4. So first we're going to make y equals 0. If y equals 0, then we have 2x equals negative 4 because y is 0. Okay, so then x would equal negative 2. So when x is negative 2, y is 0. Okay, and then the second thing that we'll do is make x equal 0. So then 2x would just be 0, and y equals negative 4. So that's pretty easy. 0, negative 4 is our other point. Okay, so 0, 1, 2, 3, 4, right there. Oops, 4. And then we just go ahead and connect those. Okay. All right, moving right along. Graphing a vertical or horizontal line. Okay, so your vertical lines will be straight up and down, and they are going to be an x equal. Your horizontal lines will be left and right, and that will be a y equals. Okay, basically what it means, it doesn't matter what x is, y is just always this value. Okay, so I'll give you an example of each. Okay, if we were to graph the line y equals 1. And you're like, well, but what is x? It doesn't matter. No matter what x is, y is 1. X is 0, y is 1. X is 1, y is 1. X is 2, y is 1. Doesn't matter. So that's going to be a horizontal line at 1. Okay, and then if I were to graph something like x equals 4, doesn't matter what y is. If y is 0, x is 4. If y is 1, x is 4. If y is negative 3, x is 4. Okay, and so then that would be your vertical line. There we go. Okay, all right. Next one. We have finding x and y intercepts. Okay, so this is really kind of building on the one that we just did a little two ago. Finding the x and y intercepts. You guys are really going to cruise through this. Of a line. Given the equation, and they're calling it advanced. You guys are advanced. You got this. Okay, so I think the only thing that's making this advanced is that there's fractions involved. Okay, so again, your x-intercept, y is 0. So you'll have an answer of whatever the x-intercept is, 0. Your y-intercept, x equals 0, so it'll be 0 something. Okay, so for the example that I've got here, we have negative 4x plus 6y equals 21. Okay, so first of all, if x is 0, then that first term, negative 4 times 0, would just be 0. And we have 6y equals 21. Divide by 6. And they're probably going to want you to simplify that fraction. Since both the numerator and denominator are divisible by 3, we'll have 7 halves. Okay. So 0, 7 halves is our y-intercept. Okay, if the x-coordinate is 0, then we're only on the y-axis, we're looking at our y-intercept. Okay, now if y is 0, then we'll have negative 4x equals 21, and x will be equal negative 21 fourths. Okay, so negative 21 over 4, 0, that is going to be our x-intercept. Okay, next one. Finding the slope given 2 points. Oh my goodness, you guys love these. Find the slope given 2 points on the line. This is just back to middle school math, right? You guys are so good at this. We want to find the slope through the line passing through the points negative 4, 7, and 2, negative 8. Okay, so remember m is y. The difference in the y's over the difference in the x's. And just make sure you do them in the correct order. Okay, so we could do 7 minus negative 8 over negative 4 minus 2. Okay, what we don't want to do is be like, okay, I want to do 7 minus negative 8, and then I want to do 2 minus negative 4. You can't do that, okay, because you're reversing the order. The negative 4 goes with the 7. They're both first. The 2 goes with the negative 8. They're both second. And you can switch that order, and I'll show you that. We could do negative 8 minus 7 over 2 minus negative 4 if we wanted to. Okay, but here we're going to get 15 over negative 6. Divide them both by 3, so 5 over negative 2. Okay, and then if we did it the other way, we'd have negative 15 over 6, which is negative 5 over 2. And as we know, it doesn't matter which number has a negative. In fact, we probably want to write it as negative 5 over 2 like that. Okay? All right, next one, graphing a line by first finding its slope and y-intercept. So this is going to be kind of like how we, the ones that are in standard form. Here, I'm going to write before I talk. Okay, so we're going to have something like negative 3x plus 4y equals negative 4. Okay, well, in the previous topics here, we just showed how this is standard form. We can find the intercepts and graph it that way. But they're saying here we want the slope and the y-intercept first. Okay, so we're going to go from ax plus by equals c, standard form, to your graphing form, y equals mx plus b. Okay, so we do that by solving for y, rearranging it so it's solved for y. Okay, so we'll add 3x to both sides. So we'll have 4y equals negative 4 plus 3x. And then we'll divide by 4. And we'll divide everything by 4. Okay, so on the left side we'll have y. Negative 4 divided by 4 will be negative 1. And 3x divided by 4 will be 3/4 x. And we do want to split that up like that because that gets you your mx plus b, right? Y equals mx plus b. So our y-intercept is negative 1, and our slope is 3/4. Okay, so when we graph it, we'll go to our y-intercept of negative 1. Okay, so our y-intercept at negative 1. And then our slope is 3/4, so our rise is 3, so 1, 2, 3. And then our run is 4. 1, 2, 3, 4. Okay, so we'd have our 2 points there. And our line will go through them, just like that. Okay, next one, we are cruising. This one is writing an equation in slope-intercept form given the slope and a point. And it'd be nice if that point was the y-intercept, but it's not. Okay, so example, if we have the point 8, 9, and our slope were 5/4. Okay, so we can right away get y equals mx plus b, so y equals 5/4 x plus b. Okay, so slope first. Okay, we don't know what b is, but we do know a point that makes this equation true is the ordered pair 8, 9. Okay, so now we can plug in point to solve for b. Oops. Okay, so we can do 9 will equal 5/4 times 8 plus b. Okay. Well, when you do 5/4 times 8, remember it's easier to do 8 divided by 4 first and you get 2, and then times 5 you'll get 10. So 9 equals 10 plus b. So subtract 10, -1 equals b. Okay, so now we know m and b, and we'll have y equals 5/4 x minus 1. Okay. All right, we got another one here. Oops. Write the equation of a line through 2 given points. So it's just one more step than what we just did. We have to find the slope first, and then you can use either point to solve for b. Okay, and they actually give you the points on a graph. So they actually give you the graph of a line, and you just take a look at it, and they give you 2 points to use on it. Okay, so the one that I'm looking at, I see a point at -6, 3, and then 2, 1. Okay, so again, we want y equals mx plus b. Okay, m will be the difference in the y's over the difference in the x's. Oops. So we can do 3 minus 1 over -6 minus 2. Okay, so we'll have 2 over -8, which is -1/4. Okay, so now we have y equals -1/4 x plus b. And now we can use whichever point we want. And you can pick. And most kids would probably pick 2, 1. Smaller numbers and no negatives. So 1 equals -1/4 times 2 plus b. So 1 equals -2/4 plus b, which is -1/2 plus b. So if I add 1/2 to both sides, I'll have 3/2 equals b. Okay, so y equals -1/4 x plus 3/2. There we go. Okay. We're getting close to the end here. Next, we have writing the equations of vertical and horizontal lines through a given point. Okay. Of vertical and horizontal lines through a given point. Okay, so again, remember your vertical lines will be x equals, your horizontal lines will be y equals. Okay, so they give us the point here in this example. They give us a point -3, -7. Okay, so you literally just have to look at what x equals and what y equals. That's it. Okay, so this is x, this is y. So your vertical line is going to be x equals -3. Your horizontal line is going to be y equals -7. Done. That's it. Okay. All right, a few more topics here. So the next one that comes up is graphing a vertical or horizontal line. what did we do up here? I'm going to scroll back. I feel like for some reason, some of these repeat. Yeah. So the next one that came up for me is graphing a vertical or horizontal line. We've already talked about that. After that is writing an equation in point slope form given the slope and a point. And we've already done that. Okay, so we already did that one. I'm not sure why they have these duplicated in two sections. The next one is writing the equation of a line through two given points. Already got that. And then the last one is writing the equations of vertical and horizontal lines through a point. We've already got that, which means we are done. And this was a nice, easy module for you guys. Hopefully you speed right through it and get a little confidence boost there. So nice job.